All right, guys. We just realized that we started this whole thing. This is on us for not doing an audio test.
Oh yeah, I was kind of right into it.
We just realized that we started the podcast and we were muted. So, that probably looked ridiculous. And I'm glad that we caught it this early on.
Yeah.
But we are going to switch back real fast so we can double check and make sure that our audio is sounding good, because
Yes.
we're learning from that mistake.
Yep. Right now.
And we're going to do an audio check. And then we'll be right back and we'll just redo everything that we just did.
Yes.
So,
see you guys.
yeah.
Whoops.
Okay, we're doing another quick audio test because I made a few adjustments just to make sure that our levels were more on par, and that we have our compressors slightly, we lowered it slightly. So yeah.
Yes. All right. Compressor is done a little bit less.
And now we're talking at the same time. Same time.
Same time.
Okay. Hey everyone, welcome to ThetaWave podcast.
Hello.
My name's Ryan. I'm here with my co-host, Jacob Holland.
Mm-hmm.
Jacob is a neuroscience researcher and actor, singer, and as I said before, an all-around wonderful human being.
Oh, you too. Love being with you here.
Stop it.
Oh my God.
And I am a machine learning expert as well as a neuroscience researcher and enthusiast as well.
Mm-hmm.
And a songwriter and singer as well.
Yeah,
A lot of overlap there in our
that's
interests.
for sure.
So today we are doing a nootropic topic, and we've got a really interesting one.
Yes, very interesting.
We are going to be covering Emoxypine Succinate.
Ooh.
Yes. And besides having a really fun name to say,
Mm-hmm.
Emoxypine is really interesting for a couple different reasons.
Yeah.
As you mentioned in our earlier version of this, it is called by its brand name that it's called by is Mexidol, and that's
Yeah.
a Russian
Mm-hmm.
company because Mexidol and Emoxypine is used over in Russia
Yeah.
quite frequently.
Mm-hmm. Yeah.
It's used kind of almost similarly, it seems, to the way we use ibuprofen
Yeah.
here. It's
Mhm.
very, very available,
Yeah.
but way more healthy than ibuprofen.
Oh, that's for sure.
like-
It's kind of like a household product that does a bunch of various things for
And
various conditions.
that's the other thing that's really, really interesting about this particular compound is the fact, we called it on the title that of our live stream, the Davinci drug or
Yeah.
something, because the similar to the way that Davinci was a really good at doing a lot of different things,
Yeah.
and kind of well known for
Mhm.
just being able to branch into a lot of different areas.
Yeah, you can't really pin him down to one particular,
Mhm.
thing that he does. He does
Exactly.
so many great things in various fields.
Exactly, and Moxipine is similar in that
Yeah,
regard.
yeah.
It seems to encompass a lot of different
Mm-hmm.
areas and influence a lot of different areas of
Yeah.
the body.
That's for sure.
And there's been a lot of different interesting research, mostly done over in Russia.
Yeah. Mhm.
On Emoxipine, and so we're gonna kind of touch on some of the research that's been done on that today,
Yeah.
as well as some of its mechanisms.
Mhm. And its key chemical components and constituents that give its, meaningful kind of like understanding of why it's able to do so many pleiotropic, various kind of fundamental modulations of seemingly unrelated systems, yet somehow do key vital, almost like specific interactions with various different mechanisms.
Right.
And we're going to really dive into that today. And it's really interesting because there's such a discrepancy between kind of the more Eastern European understanding of Emoxypine Succinate and how extensive the research has been over there. But there has been no insight by the FDA or other health regulatory agencies in the West.
Pharmaceutical companies in the West, yeah.
Yeah, they've really just almost completely ignored it. It's crazy. It almost seems intentional that they ignored it because it's like, come on, guys.
Well, a lot of this stuff kind of feels intentional to us because of the fact that it's research that we'd like to see done, but it's really just a product, a scenario, a product of the system that's set up. It's like in a capitalist, without getting into capitalism, but
we're not going to talk
in
about
a capitalist
that too much.
system that is motivated by money and kind of companies. A company's not going to want to invest into a product that is just, good at doing a lot of little restorative, stuff and is in most likely is not going to want to invest the time into researching that themselves.
Yeah.
Because it costs a whole lot, again, because of the system.
No, exactly.
And partly because of the system. And so because of the lack of research, I feel like they're not able to get, no company would be able to get, the approval needed. And without the approval needed, you can't sell it. So or you can't sell it for human use.
Yeah, exactly. But you can buy it for research purposes.
Right.
So if you're a lab out there, there are ways to get a hold of this.
Do research on this stuff.
Please do research and, kind of bring this over to where we are, because it is really such a wonderful compound that is such a good safety profile. It has been validated through extensive, studies, and there have been many even meta-analysis of the overall kind of health implications of it. It all looks very, very
It kind
good.
of reminds me of the safety profile of some of the race tams.
Yeah.
Like in the sense that, the race tams are a little more specific than Emoxypine is, but in the sense that though there hasn't been a whole lot of research outside of Russia on them, and even though they've been around for a while, and they seem to just be really solid, good compounds for improving,
absolutely.
Mental health and performance, especially as you age, as an adult, and could provide a lot of benefits over time for people in maintaining or improving, their health in some way or another. And it's kind of one of those things that, like, when pharmaceutical companies are looking for drugs, typically they're looking for something. They're first off looking for something specific.
Yeah.
And they're also looking for something that is really, really good and powerful at doing what it's intended to do.
Yeah, and it's usually one specific thing that I want it to intend to do.
And so, something like the race tams is like, they're not going to fix something immediately. Typically, they're going to provide subtle improvements.
Yeah,
and especially over time, but they're not that they don't fit the profile for what a pharmaceutical company would look for.
Yeah,
exactly. At least what in Western, in the Western medicine.
Exactly. Alrighty, so
Emoxypine. Why don't you give us the old intro and kind of break it down as far as what it is, what it's composed of?
All right. So a little bit of a chemical understanding. It's a chemical component. Its name is 2-ethyl-6-methyl-3-hydroxypyridine. Okay. And that's really important.
And that's the Emoxypine part of it?
That is, so that's the Emoxypine part of it. And the important part of it is that 3-hydroxypyridine, because hydroxypyridine is actually an analog of pyridine, which is B6. Okay. And so B6 is a absolutely vital coenzyme that is involved in so many different various fundamental physiological functions in the body, ranging from metabolism to your vascular system to energotropic energy production compounds. So
you have a basis for its diverse effects there.
Yes, right there you can kind of see how we have a vital kind of component of our cellular architecture and function that it's actively kind of mimicking. And so that's kind of its core chemical component there. And one of the things that's really interesting about that probably is its ability to scavenge free radicals and inhibit the lipid peroxidation. Yeah, its antioxidant properties and its ability to inhibit lipid peroxidation. And I want you to kind of think of lipid peroxidation in in how we understand the scavenging of free radicals. So kind of that 3-hydroxypyridine component, that 3 there is 3 hydrogen atoms, okay? And free radicals, the way you actually minimize them is by donating hydrogen atoms to those kind of scavenging molecules that are having all of these, damaging effects on the cellular substrate. And so what happens in lipid peroxidation is that there's kind of like a 3-step process that happens where it gets kind of like converted into this free radical and then kind of like takes hold of another kind of molecule and then turns it into a free radical, and then it kind of continues kind of this chain reaction of free radical kind of popping out that then causes lipid peroxidation. That's kind of that chain reaction process. And what Emoxypine Succinate does is that it donates these hydrogen atoms into the free radicals that kind of stop that chain reaction. And so it's able to stabilize these free radical constituents and stop that lipid peroxidation process that usually leads to cellular death. And so you pretty much inhibit apoptosis through that mechanism, which is really cool. You can kind of think of it as like a bunch of dominoes in a line that kind of start, and then Emoxypine kind of plucks out one of the falling dominoes and kind of inhibits that chain reaction right there.
Yeah.
Which is really cool. That's probably one of its major components and kind of its minimization of these very damaging dysfunctions within a cell. And I would say that's pretty huge just for your overall general health. If we want to, since this is, specifically a nootropic topic, it's a pretty small molecule, which means that it has the ability to pass the blood-brain barrier, and it also modulates it and increases
significantly. It has a restorative effect to the blood-brain barrier as that happens.
Yeah, and that's because of its ability to actually integrate into the lipid bilayer. And so pretty much what this does is that it decreases viscosity. So it increases the fluidity of the blood-brain barrier, allowing more stuff to
more
easily,
optimal,
more optimal paths that, very vital molecules.
Permeability there, and like kind of the way that the blood-brain barrier is intended to
exactly. Yeah. And so it's able to kind of restore blood-brain barrier integrity as well as pass through it and then modulate a whole bunch of neuronal cells. Activity through the main ones that have been extensively studied have been GABA and benzodiazepine, and like that GABA benzodiazepine complex, and as well as dopamine as well. And I'm pretty sure those are the main ones, as well as acetylcholine. It's able to do that as well, and monoamine oxidase, MAO. And it does this also through this lipid bilayer integration. And so it looks like it's more allosteric in nature. It's not exactly binding to any specific receptor. What it's doing is that it's increasing the ability for vital neurotransmitters to bind to those receptors and increase the ability for them to give out signals. Yeah, and so it's doing that. And one of the things that probably I find the most interesting about this substance is its ability to actually donate electrons to the electron transport chain in your mitochondria.
So it improves ATP.
Yes. So it's actively contributing to oxidative phosphorylation that eventually leads to ATP synthase, and the ability to increase more ATP.
Which, for those that don't know, ATP is the fundamental energy component your cells need.
Yeah. And the 98% of your ATP is done in the mitochondria. And so this is absolutely vital. Like, let's say you're doing very expensive kind of energy tasks, that take a lot of effort and focus. Pretty much what Emoxypine Succinate is able to do is produce more ATP in non-specific neuronal cells that then give rise to even better energy resources for you to just focus more enhanced without any fatigue. So that's a pretty huge kind of component there.
Yeah, absolutely.
Yeah.
I could see that being almost a core mechanism in and of itself, in which it could reach a lot of different biological functions.
Mm-hmm.
You know,
exactly.
Like you talked about like the implications of it being an antioxidant and the biological functions that it could reach via that, but also through this influence on ATP. That has a large kind of range of potential areas in which it could help improve or restore functionality.
Oh, absolutely. Like in hypoxic or in ischemic conditions, for example. If you don't know what those are, it's pretty much a lack of oxygen and blood flow to your cells. And
which can, in the brain, I know can induce strokes and whatnot.
Yeah, strokes, seizures. It even is a major contributor to Alzheimer's and other various physiological implications. And actually talking about Alzheimer's would be pretty cool. But before I do that, ischemia and hypoxia, right? So pretty much what Emoxypine Succinate is able to do. So that succinate salt.
Oh, yeah.
That's
succinate addition to Emoxypine.
Yes. That part right there is really where you can see kind of the mitochondrial interaction. So pretty much the way it usually goes is that there's like kind of there's the actual electron transport chain, which is complex 1 all the way through complex 4. Kind of like the stages of how electrons get transported that then get the final oxygen donator at the end. And that's usually how you then turn that into the water molecules that then go to the last binding site that produce ATP. But what happens during global ischemia or just ischemia in specific cells is that pretty much they don't get that vital input into complex 1 that starts that propagation into eventually ATP. And usually when that is inhibited, what happens is that your mitochondria is unable to produce ATP and the electron transport chain gets backed up. And so then it becomes dysfunctional, dysregulated. The proton gradient just gets absolutely destroyed. And then eventually kind of leads to just neuronal death because your cells don't have energy to survive. And pretty much what succinate does is that it bypasses complex 1s and then starts the electron transport chain in complex 2. Because it's succinate is one of the vital kind of components of the inner mechanisms of that part of the chain reaction of electrons. And so
it's almost like it upgraded its ID from a visitor's pass to like a VIP.
Yeah, exactly. So it's like, get out of the way, complex 1. I'm going
straight to zone 2.
Yeah, exactly. And so pretty much while the cell isn't getting blood flow and oxygen and all of the necessary nutrients that it needs to start this mitochondrial activity, succinate can actually kind of act as like an emergency battery, emergency kind of power generator for this ATP synthesis. And that is absolutely huge under these kind of conditions where they can have
so it's like instead of filling
effects.
Your gas tank, you're injecting fuel right into the engine.
yeah, that's pretty much what it is. Over longer periods of time, it might become not quite as functional as the entire mechanism, but under conditions where it's very vital that we keep the cells alive so that there isn't any long-term damage, then it becomes absolutely huge. Like during ischemic hypertension, for example, when that kind of blood flow goes back into the cell, then you have to be careful about the dosing of Emoxypine Succinate. I know that because you can get actually too much succinate and then back up the chain. And so it's all about kind of timing and precision there. But then under normal blood flow conditions, all it does is it acts as a catalyst for more energy. And so you can just overall, as a cognitive enhancer, increase that energotropic kind of component of the drug. Yeah.
So while we're on the topic of the succinate addition, let's talk about its influence on the monoamine oxidase system.
Yeah.
Its modulation, modulatory effects and whatnot.
Yeah. Okay. So pretty much it kind of has this dual modulatory effect. It's
it like doesn't stimulate and it doesn't reduce monoamine oxidase activity.
Yeah.
Like a lot of things do. Instead, it has this modulation effect where it seems to like reduce levels when they are too high.
Yeah.
And increase them when they're too low.
Yeah, so if this enzyme becomes kind of like excitotoxic in a way and produces too much oxidation, pretty much emoxypine can reduce that without actually hurting the enzyme's actual, function within the body, which is
for those that don't know, monoamine oxidase are the enzymes in your neuron synapses that are responsible for breaking down the neurochemicals, or one of the mechanisms that are responsible for breaking down neurochemicals, and as a kind of a control mechanism within there to prevent issues, from rising from too much neurochemicals accumulating in the synapse. Has a lot of different mechanisms of doing that. Diffusion, reuptake, things like that. But monoamine oxidase is one of them. And so by having a modulatory effect, instead of forcing it one way or the other, it allows for a more dynamic approach.
Yeah, because that succinate part, it reduces its inhibiting activity, and so you're getting more interaction instead of more breakdown of key neurotransmitters.
And for those that know about monoamine oxidase inhibitors and things like that, that's an example of something that pushes it in one direction.
Yeah,
it reduces the activity of monoamine oxidase by enzymes by binding to them either temporarily or permanently, and thus reduces kind of the breakdown of neurochemicals within a synapse, which can be useful for specific reasons and treating specific things if that's what's going on. But a modulatory approach is a much healthier long-term approach to kind of dealing with that.
Yeah, exactly. That's definitely a very interesting role it has there, kind of like that dual act of modulation that allows it to, make sure it doesn't get too excited, and cause a lot of damage and reduce kind of the amount of neurotransmitters it has.
And on that kind of topic, since it's a good branch into it, kind of brings us to the one of the interactions that was actually the reason why I found Emoxypine Succinate, which was which is its interaction with dopamine.
Yeah.
Specifically, it has been found to have an interaction with the dopamine system, primarily that it can help increase levels of dopamine in the brain. And it does that through actually not directly interacting with the dopamine receptors.
Yes, that allosteric modulation.
But instead, by preventing the oxidization of dopamine within the synapse, because dopamine is very prone to oxidization.
Yeah.
And that tends to happen, fairly quickly for dopamine.
Yeah.
And so by preventing that process, it's able to keep dopamine around in the synapse longer, and thus increase overall dopamine levels. Which is, another one of those fascinating interactions where most of the time when we think of something influencing your dopamine system in a drug context, we think of, primarily of stimulants, causing dopamine release, monoamine, oxidase inhibitors, specifically monoamine oxidase B, I believe. But this again takes a more like kind of subtle, even keeled approach, not directly doing it, but just like preventing early oxidation of dopamine.
Yeah, it really seems to have this really nice kind of general self-optimizing principle of your neurochemistry. And it's quite interesting to be able to almost to increase that dopaminergic activity while simultaneously regulating GABA and benzodiazepine and acetylcholine, to where you pretty much have, well, what's also nice about the way that it modulates GABA, for example, is that usually when you have like a benzodiazepine, that's like an anxiolytic drug, is that when you specifically target those receptors, you get this this very like drowsy feeling, a lot of brain fog, a lot of tiredness. But with its allosteric modulation process, where it's kind of minimizing that oxidation, you have actually more regulation with alertness. So you're not actively being reduced from your optimal cognitive state for like learning and focus. And so it's like self-optimizing all regulatory and stimulating properties simultaneously, which is a really cool idea, and there's a reason why it's kind of, I mean, I was reading a couple of the Russian papers, and a lot of them all kind of start out with like, this compound is a revolutionary, incredible compound that is going to change the world forever. I was like, well, I mean, honestly, it's one of those, like, if it did become kind of like an over the counter, not as expensive drug that people were able to readily utilize always, I mean, oh my gosh, I think it would kind of be revolutionary in the way that,
seems like it would definitely improve overall health and maybe lifespan.
Yeah, absolutely. And a lot of that has to do with its increase in like blood flow, for example, like that's kind of a huge thing,
Yeah.
It's we've been talking about, its nootropic properties, but also
that has nootropic implications too.
Yeah, exactly. And a lot of the other nootropic implications actually come from its ability to optimize other systems within your peripheral nervous system as well. And so, like, it's able to increase circulation in your myocardium, for example, which is kind of that area in your heart that is kind of one of those kind of main components of like blood pumping. And so it's able to increase circulation through that, as well as increase the mitochondrial energy in your heart muscle cells as well,
and protect like heart tissue during periods of low oxygen.
Yes, exactly. And it's
as well as improve microcirculation as well. And studies have even shown that it's able to stimulate the growth of new new blood vessels and the creation of like new blood pathways.
Yeah, that as well, and has all of these